square form is required when we want to sketch a quadratic function, or we can say this is a method to find the turning point. Finding turning point. And the turning point we know that is h and k. Okay. Complete square form is actually this is the complete square form. Y is equals to a x minus h whole square plus k, and where h and k is the turning point. Okay. This a decides for turning point is maximum or minimum, like this, maximum or minimum. Okay. For this situation, as we know, like when this is we should know this is a form. Okay, and when I want to expand this, I should know the expanded form of this, like y is equals to a x squared minus 2hx plus h squared. Perfect square formula I'm using. I'm expanding this. Okay, ax squared minus 2ahx plus ah squared and plus k. This is actually I want to use it afterwards. Okay. I have some examples for you. Like I have already have like three equations. One is the method. This is a general form, like here. Okay, what is when I want to make this example, like I want to make it a complete square form, I want to make also a complete square form, and I want to make this third equation a complete square form. But before that, I want to write a method in terms of a, b and c. Okay, this is a actually, but what step number one is what the x square should be having 1 as a coefficient. I mean x square should have coefficient 1. Okay, this is the first step. Do we have 1 here? Yeah. Okay, this is step number 1 is done. Here 2, I have to remove this 2. Okay, but when I remove 2, I have to consider only these two terms. Okay, what is common? Step number 1, what is common in these two? I want to remove this 2 because I want to make x square as a coefficient of 1. By force, I have to remove this. Okay, 2 is common. What is left? X square and plus 10. Because I am taking common in first two brackets only, I mean two terms only, and 5 I want to copy. So step number 1 is done. Okay, in the third example, y is equals to, I want to make x square as a coefficient of 1, but I want to remove 2, but 2 and 5 there is no common, but I want to take by force, so I will write 2 here, x square, and this 5 upon 2. This means when I multiply and copy this 3, when I multiply this 2 with 5 upon 2, 2 and 2 cancel, only 5 is left. This is a way. Step 1 is done. This is step number 1. That is step number 1. We have to make x square as a coefficient of 1. Okay, step number 2. I want to make x square and bx, not c. I want to make these two, like these two, like these two means these two, and these two. I want to make it a perfect square. Okay, I want to make a perfect square. Only first two terms. Perfect square. Okay, what's the method to make a perfect square? Please remember. What? This x I will write only x plus this b, please, this b I will make half of b, like b upon 2 whole square, and minus again b upon 2 whole square This method is called the perfect square form, completing square form. Please, the easiest method to make this equation is a perfect square. Okay, here I want to apply here. What's the step number 2? Step number 2 is y is equals to, just consider these two terms. What's the method? X plus half of b. Okay, square is, there is no square. Okay, what I will write? I will write x plus half of 8. What is half of 8? 8 upon 2 is 4 and whole square. Okay, ignore this 5. Don't consider this 5. First of all, I want to write the whole, these steps. Then I have to write minus. Okay, I'm writing minus. Whatever I have written, b upon 2, again b upon 2 whole square. So it means whatever I have written here as 4, that is half of 8, is 4. I will again write 4 whole square. Then I have to copy this plus 5. Like, it's better to write with this is plus 5. This plus 5 is coming from here. Now there is just what you have to do, just simplify now. X plus 4 whole square minus 4 square is 16 and plus 5. Okay, y is equals to x plus 4 whole square and minus is coming 11. Okay, now here we have to decide what is the value of a. Remember, the formula is y is equals to a. Okay, that's better to do like this. Y x minus h whole square plus k. What is the value of a here? A is 1. H is, okay, minus is already there. So whatever the value of here, I have to change the sign. So h is minus 4 and k is exact minus 11. So the turning point is minus 4 and minus 11. This is very important. I mean, for sketching a quadratic function, you should know to get the turning point. Okay, I'm moving to this part here. What is the step here? I want to consider only this part. So only this part. Don't consider 5 and 2. Okay, I will just copy this 2 and I will work on it. What's the method? That I have to write only x and half of this. What is half of 10? Half of 10 is 5 whole square. Whatever is written here 5, I will write minus and then square. Then I have to copy this plus 5. Then now what we can do? We can write 2. This 2 will multiply with like everything. This will become x plus 5 whole square minus 25. 25 multiplied by 2 is minus 50 and plus 5. Now y is equals to 2x plus 5 and minus 45. So it means the value of a is 2 and the turning point is, if this is plus, I will write minus 5 and that will become as it is minus 45, and that's your turning point. Okay. Okay, moving to this part. Again, this is little bit difficult just because there was nothing was common here. I have made 5 upon 2 here. Now what's the method? I have to take this part only and I want to make it a perfect square. So what I have to do, x, I will just copy x plus, okay, suppose you have minus here, suppose, and don't worry about the minus sign. Minus is there. Okay, what is the half of 5 upon 2? The half of 5 upon 2, half of 5 upon 2 means 5 upon 4. It's very simple. So 5 upon 4 whole square. This will always remain minus, even you have minus or plus, there is no problem. This will always be negative. Then you have to copy this plus 3, but after the bracket. Okay. Now what do you have to do? What you have to do? Just you need to multiply this 2. 2 multiplied by this. is 5 squared is 25 and 4 squared is 16. But remember, when you multiply 2 with this, like 2 multiplied by 25 upon 16 is 2 times 1 and 2 times 8. So it means 25 upon 8, and you have to copy this plus 3. Y is equals to 2x minus 5 upon 4 whole square minus and minus 25 8, and with minus 3 your answer is coming 1 upon 8. So this is minus 1 upon 8. Now what is the value? What is the value? What is A? A is 2, and the turning point HK is this. If this is negative, this will become 5 upon 4, and this will become minus 1 upon 8. Okay, this was the first, one method that how we can use perfect complete square method. But there is a other method, this by comparing and expanding the equation and get the turning point. So this is the second method I want to use, and I want to take this example. This is little bit difficult. I want to take this example here, and I want to use different method. Okay, method is what? This is the second method. You can also use this method. Okay, this method is, okay, the method is what? I want to copy this question first. Y is equals to 2x squared plus 20x and plus 5. Okay, students feel that this method is easier than this, because this sometimes we are not able, like this type of question is most difficult part when there is no common. But you can use also this method. This is optional. This is up to you. Okay, what's the method? I have to copy this equation also. Okay, remember I have also expanded this form. The expanded form is here. I want to copy this. This is expanded form. This one. This is expanded form. Okay, so what I have to do, I have to compare. I do the comparison between these two equations. So what is the solution here? And I have to copy this, the whole equation, ax square minus 2ahx, and students can just remember like by heart this equation, and you can write equals to the whole equation, 2x square plus 20x and plus 5. Okay, what's the method? What the student do here? Like this x square, there is no x square, and this x square. Okay, so they can write, or you can write 2x square. X square is equal, same, so you can write a is coming to. Okay, the value of a is coming to. We have done the first step. This is okay. Second, here is only x, here is only x, there is no x here. So this one, this part, this will be equate with this 20x. So what I can write, minus 2ahx is equals to 20x. Now this x cancel out. So what is left? Minus 2ah is equals to 20. What is the value of a we have found here? This 2, minus 2, this 2, and h is equals to 20. So h is coming 20 upon minus 4, and h is coming minus 5. Okay, so it means now we have the value of h also, that is coming minus 5. Okay, h we have known now. Now I am moving to third step. Third step is I have to compare the whole constant term with this 5. So ah squared plus k is equals to 5 with this sign. A is 2, okay, and h is minus 5, and k is unknown is equals to 5. So 5 square is 25 by 2 is 50. This negative is become positive. So k minus k is coming minus 45. Okay, we have all the values. Now what we have to do, we have to use this value. And I have to copy this equation, this equation here in left hand side. You can see I want to copy this. Y is equals to a x minus h whole square plus k. Okay, now the value of a is 2, value of h and the value of k. All the value I have to substitute in this equation. Now just substitute. Y is equals to a is 2 x, minus is already there, this minus and this minus 5, this will become what? Plus 5, and k is minus and then plus minus will become 45. When you write this equation, which is called the complete square form, think this part by using this method, by expanding the equation this form, and the equation you found here, do you think this is similar? Yeah, both are similar. It means there, like, it's up to you to use any of the method. There is no problem. Like here if you want to write the turning point you can write from here minus 5. You don't need to convert the sign, minus 5h and minus 45. And this is the way you can do the complete square method. And what was our requirement? That we are sketching a quadratic function. To sketch a quadratic function, we need turning point, and without turning point I cannot move forward. And for sketching, I want to find the turning point, the x-intercept and y-intercept, and when the domain is given, then the corresponding values of x.